Everyone, welcome to the second lecture upon DevOps with IITN. Today we'll be looking into the very basic foundation of cloud computing, which is VPC. So I have a picture for you in the display. Don't get bogged down by looking at the arrows, different components. Slowly and slowly we'll get a hang of it. We'll have an understanding of the different components. But to just give you a fair understanding of how does the VPC look like pictographically, so you can see a rectangular box and having some components. So that rectangular box is actually VPC, and VPC stands for Virtual Private Cloud. Uh, so it's a private isolated section of AWS cloud. So if you take an example, there can be different kind of networks. Like in an office, you are having a network where bunch of your computers are connected. So that is a kind of an isolated network. So such an isolated private section of AWS cloud has a name in Amazon terminology, which we call it as VPC. We'll try to understand in more detail what is the VPC. So just keep patience and do not get if you don't understand this picture at the right moment, I will let you know that you will understand it finally. So coming to the definition, what is VPC? So as I told, you can see the definition. It will expand to virtual private cloud. So if you see the words here, it's first of all it is a cloud. Okay. Second, it is private, means anyone cannot access it. And third, it is virtual, that is not physically existing. So by the definition only, if you see the acronym of it, you will try to understand that it is something which is not physical, which is very much secure and private, and it is on the cloud, it is not on the physical layer. So that basically gives us to its features, that it is a logically isolated network. Now what do we mean by logical isolation? Now logical isolation means that they are not physically isolated, but they are not interconnected to each other. Okay. You can also control a good amount of components in this, ranging from IP ranges, subnets, gateway, security. So don't worry if you're not able to understand this concept. Coming to one of it which we have to understand right now is the IP ranges. So I hope we are aware about the IP, which is the internet protocols. For every machine is having a definite name. Okay, so that is called IP. Let me know if you need, please comment if you need more information on IP. I will make a separate short video on IP so that you guys have that understanding. But for this lecture as of now, we do not need much understanding. We just need to know that IP is address of a machine. Like your address is Lajpat Nagar, so the IP is having the address of the machine. Now think it think of it as your uh, data center inside AWS. So as we discussed in the last lecture, AWS is having different regions, and there's a region is Mumbai, there's a region Hyderabad. So you can think it as your own isolated data center inside those regions. Okay. If you come to the features of VPC, we have to understand that it is very customizable. You can control a lot of features. Okay, we already discussed that it is very secure, it is private, isolated. Uh, so, and it can connect to the internet, on premises, other VPCs, and could also integrate with all other AWS services. So, I can let you know that the theory of part of the VPC is very critical to build a strong foundation of DevOps. So, although it's very easy to do lab practicals on AWS, but understanding what is the essence of VPC, that is very important. So, I would like you to keep on engaged with the theory, so that it will be very helpful for us while we do the practicals. We understand the essence of it. So let us list down the components of the VPC. So we don't have to mug up this. We just need to have a basic overview of all the components that we are having. So the first component is the CIDR block. So CIDR block is nothing, it is the IP range. So as we discussed now IP, so IP is an address of the machine. So now if there's a range of IP, like I want to have a CIDR block of 10.0.0.0/24, so that defines a range of IPs. Okay, so let me know if you want a separate video on this CIDR block as well. But as of now, we are good to go, and we do not need to delve deep inside into it. Now, uh, the another component of VPC is subnets. Now, subnet is nothing. It is just the VPC is divided into smaller networks. Like take example of your office. Now, your office can have multiple functionaries. Like there is an HR, there is a tech, there is a sales. Now, you divide them into smaller network. Okay, so that is what is a subnet. So if we go back to our picture, you'll start understanding that the rectangle that we were discussing is AWS VPC, and this VPC has been divided into two subnets. You can check the small rectangles. The one is the public subnet, and another is the private subnet. Now here we don't have to bog down about what are different types of subnets, but yes, we have to understand that this is the segregation that is present in the VPC. There is another component that is route tables. Now route tables, you consider it as a firewall, so it basically controls the network traffic. So if we take example of the office network, suppose you would want that your employees are not able to access certain websites, for example YouTube, you would want them to be productive, so you can control what traffic you want to get out of your network, also what traffic you can accept. You you also may want to block those websites that may be responsible for hijacking, so that you can control through route tables. Another component which we are having is internet gateway. Now internet gateway basically enables internet access. Okay, we'll go through this in detail. NAT gateway is basically try to understand as a component that is used to access internet for private subnets. Okay, again we'll dive deep into this. Security groups and network ACLs, these are again firewalls. Okay, so a route table is also kind of a network traffic routing, and these are firewalls that will control what can come inside and what can go outside. There are other two components also, VPN gateway and endpoints, but those are advanced level components that we'll deal with later. So the list is just to give a brief overview of what are the different components are. Uh, yeah, so let's come to the CIDR block. So you can see the CIDR block stands for classless inter-domain routing. So we don't have to understand this acronym part of it. Let's see an example. So suppose you have been given an IP like this, 10.0.0.0/16. Now I'll tell you a way to look at this. Now you can see that the IP is comprised of four parts. If you split it on the basis of dot, so it is 10, then it's 0, then 0, and there's 0, and then there's slash and 16. So let us try to understand different meanings of this. Now, if you look at the slash component, which is 16 here, so that basically means what number of bits are reserved for the network address. So if you see the our IP is composed of any IPv4 address that is composed of four components, each of having 8 bits each. So the 10 is of 8 bits, so you can represent it into the binary format 0 1. The 0 is again 8 bit, again 0 is the 8 bit, and again 0 is the 8 bit, so you are having total 32 bits. Now when you say /16, you mean that your 16 bits are reserved for the network and 16 bits can be used for subnetting. So that means your 10.0 will remain constant, and you can change from 10.0.0.0 to 10.0.255.255. So if you sum this up, you will come through 65,536 IP address. So We don't have to calculate this number, although it is very easy to calculate. We just have to understand that whenever we say a CIDR of 10.0.0.0/16, we basically mean that we are creating a network which can hold 65,536 IP addresses. That means I can hold 65,000, more than 65,000 machines. Okay, so my reserved bit will be 10.0, and my network bit will be 0.0. Now, add in the comment if you want a detailed understanding of how the subnetting works, how the CIDR works. But this should be unique across the connected network. It should not overlap, and it can only expand with secondary CIDR blocks. If you come to the next component, which is subnet, which we try to understand. So you can take the example of the subnet. There are two subnets displayed in the picture. One is the public subnet, another is a private subnet. And so just let us try to differentiate between what is the difference between public subnet and private subnet. So just by the name you can get the answer to it. So public subnet is subnet that is accessible to the outside world, but private subnet is something that is not accessible to the outside world. That's the basic definition. So for example, if you are having a machine and your machine is inside a VPC and you put it in subnet, then I can access your machine if you allow me to directly. But if you put your machine in the private subnet, I will not be able to access it with your direct private IP. I will need a hell lot of different mechanism. So we'll go into more detail regarding different kinds of subnets, what are the use cases. But for the time being, this is the difference between the public subnet and the private subnet. Uh, Route tables, as we discussed, so route tables are basically deciding the traffic, how they move to the IPs. So if you basically check onto this image, you can see this is a VPC. VPC is divided into different subnets, as we can see, and then there is a route table. Route table is nothing; it is a table of entry. So what you enter in the route table, you simply enter the destination and the target. So suppose you enter a destination like this: 0.0.0.0/0 IGW. Now IGW stands for Internet Gateway. Now what does this mean? This means that any machine on this subnet, if it has to access anything 0.0.0.0/0, this will mean anything, it should use Internet Gateway as the target, as the routing network. So so this is the definition. Now if you see for the next part, you can see that this VPC CIDR is 10.0.0.0/16. Now what does this mean? This means that whenever you are trying to access this destination, you have to route locally. That means you don't need any mechanism like internet gateway or NAT gateway to access machines in the same network. Okay, so route tables are something that basically decide how does the traffic flows in the network. If you will write that 0.0.0, if you remove this entry in the route table, you will not be able to access the internet. We'll understand in more detail regarding the route tables, but for the time being we just have to understand that it is routing the network traffic inside the VPC. As simple as that. Next, if we come to the internet gateway, so internet gateway is nothing but it is a component in a VPC which is attached to a subnet, and it makes the subnet access the internet. So as we were rightly discussing now, the target in the route table was IGW. So this is an entry. It is another component. As you can see, the cloud here, it is representing the internet gateway. So internet gateway will allow all the subnets which require access to the internet. So whenever you type www.google.com, youtube.com, yahoo.com, anything, so uh, if your internet gateway is having this subnet is having this, your internet gateway, you are able to access it. Next we come to the NAT gateway. So NAT gateway is just you can think it of it as another form of internet gateway, but this is for private subnet. So NAT gateway will stand for network address translation. So let me see if I can show you in the diagram. Just okay, so basically NAT gateway is something that will enable outbound internet traffic for private subnets. So your subnets that are in the private subnet, as we said, they're not accessible to the outside world. But if you have NAT gateway for the private subnets, you are able to access internet from the private subnets. So you might need access to the internet on the private subnet, and NAT gateway is the solution for this. Uh, Again, there are two types of security controls that are present in the VPC. One is the security group and another is the network ACL. Now, the only difference between these two firewalls is one operates at the instance level and the another operates at the subnet level. We'll discuss in detail what about this, but these are just basically just a way to control traffic inside and outside of your machine. So let's summarize this what we learned so far. So we basically got the understanding of what VPC is. It's an isolated AWS network. We also got a very brief view of what are the different components of it, the CIDR, the subnets, route table, internet gateway, NAT, security group, NACL. We also try to understand how does traffic flow and security we can maintain at every level, either through security group, internet gateway, NAT or NACA. So these will basically form foundation for all of your AWS concepts. In the next lecture, guys, we'll be doing practical on VPC. There we'll try to understand more, but I would like you to revisit this lecture, understand more onto it. If you want to explore the AWS official documentation, you're free to explore AWS official documentation regarding the VPC in order to have a thorough theoretical understanding of the VPC, because that is a foundation. Okay. Please subscribe to the channel, guys, for getting alert notifications for the new courses that we are launching, and also comment for the suggestions whenever you are having any doubt, any kind of you would need a separate assistance on that. Feel free to comment and subscribe the channel. Thank you.